Today, we are going to be looking at graphing systems of linear inequalities. So our last lesson, we graphed just one linear inequality, but now we're going to graph a system of them, so two or more. So the steps to solving a system of inequalities. First thing you're going to do is put all of the inequalities in slope-intercept form. If you remember, that is y equals mx plus b. Then you're going to graph the first line with the shading and then graph the second line. And then you are going to shade in a different color for this. So the solution is going to be where both of the shadings overlap. So things to remember. Types of lines, we are using a dashed line when it's a less than or greater than. And a solid line if it's an equal to. So less than or equal to or greater than or equal to. Shading. Before we talked about using a test point, plugging in a point to see if the statement's true or false to shade which side. Here's a shortcut. You're going to shade above the line if it's greater than or greater than equal to. And you're going to shade below the line if it's less than or less than or equal to. And above, you can also think of it to the right if it's a vertical line. And below would be to the left if it's a vertical line. And at any point you want to check, you can always use a test point for your shading. You don't have to do this trick. So let's graph here. We have two inequalities we're going to graph. The first inequality, I am going to represent it with blue. And then the second one, we're going to use red. Okay. Our first line, we have y is greater than or equal to negative x plus 2. Start the y-intercept at 2. Put your point. Then we have a slope of negative 1. So down 1 to the right 1. And this is a solid line. So let's draw our solid line. And now we're going to shade. So it's a greater than, so we're going to shade above the line. Okay. Now let's graph our second equation. We have a y-intercept of negative 2. So go down to negative 2. We have a slope of 2, so rise 2 to the right 1. Rise 2 to the right 1. And our line is going to be dashed. Okay. Now we're going to shade. And it is a less than, so we're going to shade below the line. So our solution here is where both of these shaded regions overlap. So this darker color right here is our solution. So it could be any point in this color region or on a solid line. So possible solutions here. We have 2, 0 is a possible solution. Another possible solution is right here at 3, 2. And then 4, 4. If we look on this line here, we have a dashed line. So none of those points on this line here is going to be a solution. Let's look at the next problem. We're going to use blue again for our first equation and red for our second equation. So our first equation here, we have x is greater than -1. And x equals a number, that's going to be a vertical line at the number. So at -1. And we have a dashed line here. Let's draw our line. It's going to be dashed. And now our shading. X is greater than. So we need numbers that are greater than -1. So that's going to be on the right-hand side here. We're going to shade in the right side. As you see, I'm shading the whole area. And you should be doing this with a color pencil. Our next equation here is y is less than or equal to -3. So this is going to be a horizontal line at -3. And it's a solid line because it's equal to. And it's less than or equal to, so we're going to shade below the line. So our solution here is going to be this darker region and any point that's on a solid line of that shaded region. So right through here is not a solution, but through here is and the shaded area. So some possible solutions. We have 2, 0, because it's on a solid line. We have 0, -3. And then we go over 4, 4 is also a solution. These are just possible. There's many more. Okay, let's look at the next equation. We have y is less than or equal to -x minus 1. So we are going to start off with our y-intercept here. And our y-intercept is -1. Our slope is -1, so down 1 to the right 1. Our line is a solid line, so you want to draw your solid line. And then our shading. It's less than or equal to, so we're going to shade below the line. Now let's graph our second equation. We have x is greater than or equal to negative x plus 3. Start at the y-intercept. We have a slope of negative 1, so down 1 to the right 1. Graph your line. Our line is solid. And draw a solid line. And then we are going to shade. Our shading, let's see. It is greater than, so we're going to shade above. So here, do we have any overlap of our two regions? No, we don't. So here, it's a no solution. There has to be overlap of the two shaded regions. Let's look at the next problem here. We have y is greater than 1/2 x minus 3. So we're going to start off with our y-intercept at negative 3. We have a slope of 1/2, so rise 1 to the right 2. We're going to draw our line. Our line is a dashed line. So when you draw it, make sure you dash it. Now let's graph our second. Oh, shading. Cannot forget about shading. There's always shading when you have inequalities. So it's a greater than, so we're going to shade above the line. Now our second equation. We have a y-intercept of 1, so plot your y-intercept, and a slope of 1/2, so up 1 to the right 2. Up 1 to the right 2. Draw your line. It is a equal to, so it's a solid line. And then we are going to shade. It's a greater than or equal to, so the greater than means we are going to shade above the line. So we're going to look at our solution. Our solution is where both of the lines, shaded areas, overlap. They overlap here in this darker region and on the line itself because it's a solid line. So some possible solutions are 0, 1 on the line. Let's see, 1, 3. -2, 0, and it's also on the line. Anything here is not a solution. It has to be where they overlap. Okay, let's look at an application problem. Autumn sells boxes of pasta for $2 each and a jar of sauce for $3 each. Autumn needs to make at least $12, but has no more than 8 boxes and cans combined. So, here, we're going to let x equal the number of boxes. And y is going to equal the number of cans. So we need to write two equations here. So pasta is $2 each. So we're going to say 2x, or 2 boxes, or $2 each per box. And a jar is $3 each per jar. So that we're going to add 3 jars, which is going to be our cans. So y. And it says that she needs to make at least $12. So it's not going to equal 12. It needs to be at least, so it needs to be greater than or equal to 12. And has no more than 8 boxes and cans combined. So boxes plus our cans, x plus y, cannot be more than 8. So 8 has to be greater. And it can be equal to, so it's no more than. So here are our two equations. We need to graph these. Before we can graph this top equation, we have to write it in slope-intercept form. So 2x plus 3y greater than or equal to 12. We need to get y by itself. So we're going to subtract 2x from both sides. We get 3y greater than or equal to negative 2x plus 12. Divide both sides by 3. Y is going to be greater than or equal to negative 2/3 x plus 4. Now, for the bottom equation, we have x plus y is less than or equal to 8. We need y by itself, so we're going to subtract x from both sides. So we get y is less than or equal to negative x plus 8. So we have two equations here. So these are our two equations we are going to graph. So we're going to start at our y-intercept at 4. We have a slope of negative 2/3. So down 2 to the right 3. Down 2 to the right 3. Graph the line and it's an equal to. Oops. Try that again. So it's a solid line. Now we are going to shade. Shading is greater than, so we're going to shade above. We're talking about money and cans and jars, so physical things. That's why we're only looking at the positives of x's and y's here. Now we're going to graph our second line. Negative x plus 8. So we're going to go up to 8. Plot our point. Slope of negative 1, down 1 to the right 1. We're going to graph it. After we graph it, we need to make sure that our solid line is correct and it's unequal to, so it's a solid line here, and we are going to shade below because it's less than. So we're going to shade below the line. So with us shading below, we need to find some possible solutions, or a possible solution. So anything in this region here, in between these two lines, where the two colors overlap, that is a solution. It can be on either line as well, since they're solid lines. So let's look at a possible solution. So X's are our boxes. So we could do 4, 3 as a point. So what that means in our problem is she can sell 4 boxes and 3 cans or jars. So that is your lesson on systems of inequalities. Please reach out if you have any questions.